Hello everyone, this is class number 15. Today we are going to discuss about mathematical library functions in Java. But at first you have to know what mathematical library functions are. Java has several predefined classes and various predefined methods into it. Similarly, Java math class has many predefined methods that allows us to perform various numeric operations generally on number passed as argument through them. This math class belongs to java.lang package, which is a default package. This class provides more than 50 functions, but in today's class we are going to discuss about only 26 of them. So welcome to Classroom Computer. Let's start. At first, all of you have to know about NaN, because in this class you will see that at some point for a specific argument or input, some methods returns NaN. NaN stands for not a number. This output is produced in a floating point operation, has some input parameter that cause the operation to produce some undefined result, like 0.0 divided by 0.0 or square root of a negative number. Both are undefined. Starting with the first function, which is Math.abs. This abs word stands for absolute value. So this function returns the magnitude of a number. The data type of the number is unchanged. Only the output comes without a sign, a positive value. We can pass integer, float, long and double value through this function. Here is the basic syntax of the function. Now come to an example. In this program there are 4 variables: integer, float, long and double. X is an integer variable and value of x is 4. F is a floating point variable and the value of it is minus 96.663. L is a long type variable and the value of it is minus 1, 2, 3, 4, 5, 6, 7, 9. And the last one is D, which is a double type variable, and the value of it is plus 56.2213. And the double D here is with a plus sign. This method also works on constant. So in output, the first value passed into ABS function is minus 4, which is a constant. In next 4 input, we passed X, F, L and D respectively. Now in output screen, you can see that all values come without sign. Minus 4 becomes 4 and minus 96.663 is 96.663. Minus 1, 2, 3, 4, 5, 6, 7, 9 is 1, 2, 3, 4, 5, 6, 7, 9. And plus 56.2213 is 56.2213. No sign. The return type is same. The next function is CEIL function. CEIL function only take double value. If you put any integer value into it, then it returns the double form of that integer value, because the return type is double. This method returns the smallest double value that is greater than or equal to the argument and is equal to the integer value with a 0 after decimal sign. Like if we pass 3.2, then it returns 4.0. If we pass minus 4.6, then it returns minus 4.0. Now come to the example. In this picture, I combine both program code. This is the program code and the output screen. Here is the output screen. In this program, we pass 3 variables X, F and D. The first one is integer, the second one is float and the third one is double. For integer value, the input of X is 4. So the output is 4.0. For float F, minus 96.66 is minus 96 and for the double value 56.2 is 57.0. This first print statement returns 4.0 because the return type of the function is double whatever the input in numeric form. This minus 96.66 is minus 96.0 because minus 96.0 is the smallest whole number which is closest to minus 96.66 and greater than it. Remember these four words: smallest, closest, whole number or integer, and greater. Similarly, for third input D, 56.2 becomes 57.0 because it also smallest, closest, integer, and greater than 56.2. So we take 57 and put a 0.0 after it to make it a double value. This function also works with constant, but remember the argument should be numeric and single. Next is floor function. Floor function only take double value like cell function. If we put any integer value into it, then it returns the double form of that integer value. Because the return type of this function is double, this function returns the largest double value that is less than or equal to the argument and equal to its integer value with a 0 after decimal sign. Like if we pass 3.2, then it returns 3.0. If we pass minus 4.6, then it returns minus 5.0. Now come to the example. In this picture also I combine the program part and the output part both in a single window. So here is the program and here is the output. In this program we pass three variables x, f and d. The first one is integer, second one is float, and the third one is double. The value of x is 4, so it returns 4.0 because the return type is double. For f, minus 96.66 becomes minus 97.0 because minus 97.0 is higher whole number which is closest to minus 96.66 and less than it. Remember this four word for floor function: highest, closest, whole number or integer, and smaller. Similarly, for third input D, 56.2 becomes 56.0 because it's also highest, closest, whole number and smaller than 56.2. So we take 56 and put a 0.0 after it to make it a double value. This function also works on constant, but remember the argument should be numeric and single. It is a very common question that what is the difference between CEIL and floor function. The only difference between them is CEIL function returns the smallest integer value which is greater than or equal to the specified number, whereas the floor function returns the largest integer value which is less than or equal to the specified number. In the scale you can see for negative number we consider the left hand side, and for positive numbers we consider the right hand side of the scale. So for minus 2.56, Math.ceil equals to minus 2.0, and Math.floor for minus 2.56 is minus 3.0, and for plus 2.56, Math.floor is 2.0 and Math.ceil is 3.0. This scale you can see the difference between Math.ceil and Math.floor very clearly. Next, Math.rint. This method returns the nearest integer value of the fractional number provided as an argument. So the return type of this function is double, but there is a thing: if the value before the decimal point is even, then it returns previous integer value. If odd, then it will return the next integer value. Now clarify this with an example. There are three variables: x, f and d. They are integer, float and double respectively. The value of x is 4, the value of f is minus 96.66 and the value of d is 56.2. This picture also combines both the output window of the program. The first println statement print the value of x but in a double form. because the return type is double, 4.0. The next print statement, print the rint value of minus 96.66, which is minus 97.0. The third output statement, print the rint value of 56.2, which is 56.0. The function can also take constant as an argument. So in last print statement, argument is a constant, which is 56.9, so the output is 57.0. If the value after decimal point is greater than 0.5, then after rint it will add +1 with the value before decimal point. But if the value after decimal point is less than or equal to 0.5, then the value before decimal point remains same after rint. The next function is Math.round. This function or method rounded value up to the nearest integer. The return type of this method is long or integer. If the argument is float, then the return type is integer, but if the argument is double, then the return type is long. And if the value after decimal point is less than 0.5, then it returns same integer value. Otherwise, it returns the higher integer value. Let's understand this function with an example. This picture also combines both the program code and the output window. The first output is rounded value of 4, which is 4, because it's already rounded. So the return type is same, integer. The next input is f, whose value is minus 96.66 and it's a float value. The value after decimal point is 0.66, which is greater than 0.50. But the original value is in negative. So after rounding it, it decreases its value. So minus 96.66 becomes minus 97. Now in third output, we print D, which is a double, 56.2. This 0.2 is less than 0.5. So the integer part remains same. So the answer is 56. But the last print statement, the value is a constant and the value is 56.9. The fractional part is greater than 0.50. So it increases the integer part of the number and 56.9 is now 57 after rounded up. Another important difference between Math.round and Math.rint. The first difference is in return type. The return type of Math.rint is double, but the round method returns either long or integer value. The next difference is at midpoint, Math.round returns the higher integer, whereas at midpoint, Math.rint returns the integer that is even. This is going to be more clear on third point. This third point is the example of second point. In this example, you can see that rounded value of 2.5 is 3 and the rounded value of 3.5 is 4. But in case of rint, 2.5 and 3.5 both give the same output, which is 3.0. Next is Math.pow function. The pow function takes two values as argument, like for m to the power n. The first argument is m, which is base, and the second argument is n, which is power. The return type of this function is double. All arguments are in double data type. This function can take variable and constant both as argument. In example, we are going to discuss about constant only. The first output is for 3.0 to the power 3.0, so the answer is 27.0. The second input is 3 and the power is 3. Look, both input give same output, but for first print statement, inputs are in double and the second print statement, inputs are in integer. So type of the output doesn't depend on the type of the input. The third print statement, input is 5.12 and the power is 1.5. It also gives the proper output. For 5.0 to the power minus 1.0, this also gives proper output. Here the power is in negative. The next print statement, the base is minus 7.3, which is in negative. This is also give the proper output. And the last print statement, the power is 0.0. The answer is 1.0. So the POW function give output for all possible numeric values. The next one is Math.sqrt function. In this method, the argument is positive and greater than 0. Then it returns the correctly rounded positive square root of a double value passed as an argument. That means the argument should be positive and should be greater than 0. The return type is double always. If the argument is NaN or in negative, then the answer or the output is NaN. This is the example of sqrt function. This picture also combines both program code and the output window. This function also works on variable, but this program all print statement works on constant. If you want to use this function with variables, then you can put variables inside of functions instead of constants. The first square root in print statement for 16.0. So the output is 4.0. The second print statement is for 16. The square root is also 4.0. The third print statement for the square root of 52.0. The output is proper. The next one is 11.23. Here is the output is proper. The fifth one is 0.0. So the square root is 0.0. The last one, I put a negative constant value inside this function, which is minus 7.33. Look, the output is NaN. Because square root of a negative number is undefined. This is cube root. This function returns the cube root of a double value passed through it as an argument. If the argument is not a double value but numeric, then this function treats argument as double. The return type of CBRT function is double, and this function works on positive and negative both type of double values passed as an argument. Let's talk about the program with an example. As I said before, this function accepts both negative and positive numeric values as arguments. In this program, all arguments is constant, but this function also takes variables as argument. The first print statement is the cube root of 2.7. In second print statement, the argument is integer 27. The output is double 3.0. Third, fourth and fifth print statement passed positive values as argument. The last print statement, the argument is in negative. The output is also in negative. The cube root of a negative number is negative in this function. Next is Math.random. This Math.random is a function. Actually, math is a class and random is the function which doesn't take any parameter or argument in normal or in default form. If we write just Math.random in a print statement or store the value of this function into a variable and print that, then it will show you any random number between 0.0 and 1.0. So the return type of this function is double. If we see the program with output, then notice the first print statement. Here only Math.random print the first print statement, so the output is a fractional double value between 0.0 and 1.0. The beauty of this function is we can improvise this function. The first improvisation is this one. The random number between 1 and x, which is a variable. X is a variable. And the formula is int a equals to int math.random into x plus 1. This int is the explicit type conversion. In this way, this equation returns a number value between 1 and x in integer form. If we write only math.random into x plus 1, then it also returns a value between 1 and x but in a double form. Now look at the program code. Here is a variable x and the value of x is 5. Next, look at the second print statement. Here is the print statement: print any random number between 1 and x in integer form. The value of x is 5 here. So the print statement print any random number between 1 and 5. The output of this print statement is 4. Now come the last improvisation, this one. In the last print statement, only upper limit range is variable and the lower limit is constant, which was 1. But in last improvisation, lower and upper limit both are variable. This equation int I equals to int math.random into b minus a plus a. This equation returns only a random integer number between a and b minus 1. Here upper limit is b minus 1 and the lower limit is a. Now come to the program. Here a and b both are integer variables and the value of a is 10 and the value of b is 100. Look at the third print statement. Here also int inside the first bracket is the explicit type conversion. So this statement print any random number between 10 and 100 minus 1. So the output is 98. Now if we remove this int, then this statement also print a random number between 10 and 100 minus 1 but in a double form. So this is the double form of this output: 98.223795483777042. Now come to the next mathematical function, Math.max. This function compares between two numbers for the greater one. This function works on 4 types of variables. They are integer, long, float and double. And this function returns the greater of two values passed as arguments. You can see all 4 types of arguments with the function syntax. If we pass same values, then it returns the same value. Here positive 0 is greater than negative 0. The next is min function. This function is just opposite of max function. It also takes 2 arguments and return the smaller one. The function also takes 4 types of arguments: integer, long, float and double. Here also if both values are same, then it returns the same value, and also negative 0 is smaller than the positive 0. Now come to the program. Here you can see total 4 variables are there. A and b both are integer and I and j they are both double. Value of a is minus 67, value of b is minus 88, value of I is 667.99908, value of j is 67.0099. Now come to the first print statement. Here comparison between two constant values 67.90 and 67.901. Here 67.901 is greater than 67.90. The answer showing the same. The second print statement, both values are same actually. So now the max function returns the last value, which is 89.0. This is same for the min function also. Min function also return the second value if both values are same. You can see this in sixth print statement. Here 89.0. In third print statement, comparison between two variables a and b, and the output is the maximum one, which is minus 67. In next print statement, it also print the maximum value between I and j, which is I. Next 4 print statement print just opposite of previous 4, except the 89 and 89.0 for main function. Now for the last one, you can see I compare the value of a with a constant. That means max and min, both functions can compare variables with constant at a time. In this point, normal ICSE syllabus ends. But there are several other functions. I just want to discuss them few lines for each. The next one is Math.log. This function argument is double and return type is also double. This function returns the natural logarithm of a positive number of base e. The function doesn't work on negative number. If you pass any negative value as an argument, that it will return any n, not a number. The next one is Math.exp. This function returns Euler's number raised to the power of a double value. In this case, the double value is the argument a here. Where a is the argument, the return type of this function is double. Now some trigonometric function. At first, the conversion function, 2° and 2radian. 2° function converts angle measured to radian to an approximately equivalent angle measured in degree. So the argument is in radian and the output is in degree. In conversion from radian to degree is generally inexact. That means it calculates the approximate value to radian. It's just opposite of 2°. In case of 2radian, argument is in degree and the output is in radian. This function converts an angle measured in degree to an approximately equivalent angle measured in radian. This conversion is inexact, an approximate value. This slide is for all trigonometric functions. The first three functions, Math.sin, Math.cos and Math.tan, all three returns trigonometric sine, cosine and tangent respectively. The return type is double. The next a sine, a cos and a tan 2 returns the ICSE of sine, cosine and tangent. And last three method returns the hyperbolic sine, cosine and tangent. The last one is Math.pi. This function provides built-in constant field of pi. Let's discuss some theory questions. Conversion of mathematical expression to Java expression. Here is a list of mathematical expression, total 52. This is the first page and this is the second page. Remember one thing, don't write anything in your Java expression which you can't find in your keyboard. This is very much important. I also mentioned the year with the question here, 2015, 2013. This list also contains previous 15-year question. You can pause this video and take a screenshot for all questions list. I am going to solve some of them. The first one is question number 2. Several times this type of conversion needs some brackets. Be careful at the time of bracket closing. Next is question number 5. This question Math.sqrt use, so expression is here P into Q Math.sqrt 3 plus 0.02 into Math.sqrt R. Next question number 7. This question also need Math.sqrt, so the expression you can see here. Also at first I write -1 because the expression starts with minus b, so multiply b by -1, make it -b. Next question number 13. Before talking about this expression, I want to say something. In several answer papers, students use Math.pow when power is greater than 2, but you should use Math.pow if the power is 2. It's a good practice, a good thing to use math function as much as you can in your expression. So the expression is this. Next question number 19. This expression need Math.pow and Math.square root both. So the expression you can see Here I use several first bracket. The next question number is 22. Math.sqrt and Math.pow both works here. You can see the expression. Next one is question number 26. This conversion need Math.cbrt because two cube roots are here. So the expression you can see. The next one is question number 31. This conversion is interesting because the power is in fraction. We can pass 3/2 as power in Math.pow function. So the expression you can see this. Next question number 36. In this question we use Math.pi. So the expression is this. You can also put 3.14 or a constant value instead of Math.pi. This Math.pi use is not mandatory. Here next the question number 40. Here we use three functions, Math.pow for the power, Math.abs for the absolute value and Math.exp. You can see the expression. Next question number 45. This is an expression of trigonometric function. So we use Math.sin, Math.atan and Math.exp and Math.sqrt. The last one is question number 52. Here the question is in very small form because I don't have that much space. You can see this question in full form, very clear at previous slide. Here I use Math.pow and Math.sqrt. You can see the expression. So this is the end of today's class. If you have some doubt or question, then you can mail me or write in comment section. If you like my video, then please like and share this video and subscribe my channel and please click on the bell icon. Thanks for watching.